Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to provide with two more examples related to how you can find the coordinate, the new coordinate. For example, if let's say you have coordinate vector with respect to the old basis, how can you find the new coordinate vector with respect to the new basis here? And in order to do this example here, you have to first of all understood what's the procedure and everything, and that is already given and discussed in the previous video. So you have to go to the previous video in order to really understand the discussion that I'm going to embark on. Okay, right. Right, so let us look at this example here. We have vector space of polynomial degree 2, and here are the bases. So this guy and this guy, B prime, and you are asked to find the transition matrix. So from B to B prime, okay? Well, let me just write down here. P2, well, if you have the general look of it, it looks like this: a0 plus a1x plus a2x squared. And you can think about it if you want to write in terms of vector notation straight away. So here will be the position for constant, the position for x, and the position for x squared. Okay, well, based on that, I can write down B here in terms of 1 means you have 1, 0, 0. Okay. X, you have 0 for constant, 1 for x, 0. And then x squared means you have 0, 0, 1. So in other words, what we have here is the standard basis. Okay, you can see clearly we have position of 1, the rest all 0, position of 1 at the second position here, and the rest all 0, and finally 1 over there, and the rest all 0. So you get the standard basis. And for B prime, okay, I can write it down in terms of, well, for this one here, I have 1, 0, 0. X plus 1 is 1, 1, 0. This guy here, I have 1, 1, 1. So that is the new basis, B prime. So in order to find the transition matrix, again, let me just label everything so that it's easier for you to apply the formula and you can see what's going on, I hope. So here is vector 1, okay, and this is vector 2, and this is vector 3. The starting point, or the first step, is to try and write this vector, vector 1, as a linear combination of 1, 2, 3 from the new basis. So here I have a1, I'm going to call a1. So this is a scalar next to this vector, 1, 0, 0, plus a2, 1, 1, 0, plus a3, 1, 1, 1, must equal to this vector, the old vector, 1, 0, 0. Okay, so that's the idea. So I'm going to call this equation 1. Next is for this guy here, going to have b1, 1, 0, 0, plus b2, 1, 1, 0, plus b3, 1, 1, 1, must equal to this second vector here, 0, 1, 0. Okay, I'm going to call this the second equation. And Next is to write this vector, the last one, in terms of the combination of all these three vectors here. Well, I have C1 1 0 0 plus C2, this one 1 1 0 plus C3 1 1 1 must equal to this last vector here, which is 0 0 1. So that is the starting point. Okay, and I'm going to call this equation 3. Okay, right. Now based on equation 1, I believe that you already know what's our aim. Our aim is to find the values for A1, A2, and A3. And how can we do that? Well, so I'm just going to write down here, based on equation 1, to find the values of A1, A2, A3, we can consider the augmented matrix that combines all these values here. Okay, so we have 1 0 0, 1 1 0, 1 1 1 must equal to 1 0 0. Okay, and what we can see here, it is already in its simplest form. It is already simplified. We don't need to do any elementary row operation. And I can see that for this one here, I can write down the answer to A3 is equal to 0. So that is the answer. Based on this one here, is A2 plus A3 is 0. A2 negative A3, A2 is equal to 0 as well. And for the last one here, I have A1 plus A2 plus A3 is equal to 1. A1 must be equal to 1 since A2 and A3 is 0. Okay, so I got the values of A1, A2, A3. Next, based on equation 2, okay, the purpose is to find what are the values of B1, B2, and B3. And again, it can be achieved if you consider the augmented matrix 1 0 0 1 1 1 1 1 1, and here 0 1 0. Okay, so 0 1 0. Again, we don't have to do anything much because the matrix is already simplified. So what we can have is here, sorry, this is 0, sorry, 1 0. Now based on this, you can clearly see that for the first one here, B, yeah? So this is B3 is 0. Next is this one. We have B2 plus B3 is equal to 1. So B2 is just 1. And this one is B1 plus B2 plus B3 is 0. So B1 is negative B2 because B3 is 0 already, and negative B2 is negative 1. So B1 is negative 1. Next, based on equation 3, so again, our aim is to find the values of C1, C2, and C3, and we can do that if you consider the augmented matrix. So here we have 1 0 0 1 1 0 1 1 1, and here is 0 0 1. Okay, 0 0 1. And we are lucky because we don't need to do anything. Okay, right now here we can find the value straight away. C3 is equal to 1. For this guy here, C2 plus C3 is 0. C2 negative C3, which is negative 1. And for this one here is C1 plus C2 plus C3 is 0. C1 is negative C2 negative C3. So negative negative 1, negative 1, which is 0. Now we have got all the values of a1, a2, a3 and so on. Based on that, we can find the transition matrix. Okay, so the transition matrix is going to look like this. Okay, so based on what we have here, remember we are interested to find a1, a2 and a3, so we've got that. So in that particular order, they are going to be in this first column here. So the result here is going to be 1, 0, 0. So that is related to this vector. So here is the old vector, the first old vector, vector 1 here. Okay, now here is for b1, b2 and b3. So once you have got these values, you will consider putting that in the second column, and here is negative 1, 1, 0. So the second column here is related to, again, so here is the equation related to the O vector from the O basis as a combination of the new vectors from this new basis. Yeah. And then we move on to the third vector with the vector that has the vector here is the third vector from the O basis as a combination of all the new vectors from this basis. So we have got this value C1, C2 and C3, and that will be in this third column. Okay, so that is the process, and the result here is we start with C1, okay, in that order, because C1 is somewhere here, right? C1, C2, C3, so in that particular order. So C1 is 0, negative 1 and 1. So this is the transition matrix. Now once you have got this transition matrix, then you can answer the next question. Okay. Okay, so the question here is asking you to find what is this coordinate vector of px relative to new basis b prime relative to this, and it gives you this polynomial of degree 2. So I'm just going to write down here. So it gives you px is, well, 3 minus x plus 2x squared. So 3 minus x plus 2x squared. And that is px. Now we can consider that as the usual vector notation would look like this: 3, negative 1 and 2. Okay. Now what is the formula to find this one with the new basis? The formula is easy. We need the transition matrix, which we have already obtained here, and we need to multiply that with the coordinate vector of px with the old basis. Now what we have here is just px. This is just px. So px with the old basis is going to be the same thing. Why is it the same thing? Because the old basis here is the standard basis, and I have already explained in the old video about what happens when you have a vector and a standard basis, and therefore the coordinate vector with respect to a standard basis will be itself. So it will be itself, and we don't need to do anything much. So in this case, because B here is the standard basis, let me just reiterate my explanation. So this is the standard basis. Therefore, the coordinate vector with respect to the standard basis will be the vector itself. Okay, and therefore we can just continue the process with plugging in the transition matrix 1 0 0 negative 1 1 0 0 negative 1 1. So this guy here 3 negative 1 and 2. Well, based on that, you can obtain the answers. Okay, so the answer here is going to be this one, and with this column, so 3 plus 1 is 4, 0, well 0. Next, this guy and this guy, so negative 1, negative 2, negative 3, and then finally this one here 0 0 2. So this is the coordinate vector of px with respect to the new basis. Now let me just tell you what does it mean when we have 4, negative 3, 2, and so on. So when we have this, remember what is this stuff. So in simple words, when you have all this thing, it means that the vector given, which is in this case is px, is equal to 4 times with the first vector here. So the first vector here is this one, or you can write down in terms of this value. So 4 times 1, you can do that, plus negative 3 with the second vector here, or this guy, x plus 1, plus 2 with this guy here, or this guy. Okay, so that is x squared plus x plus 1. Okay, so that is the meaning. And what is v or px here? This guy here is just this thing, 3 minus x plus 2x squared. So this thing here comes from, so this here is just this one, the vector px. Okay, and well, you can try and simplify that. So you will get 4 minus 3x minus 3 plus 2x squared, 2x plus 2. So 4 minus 3 plus 2, you will get 3. And then negative 3x and 2x, you get negative x. And then plus 2x squared. And you can see that exactly this is equal to the given vector here. Okay, so that's the idea. Next is the last example related to how you can change the coordinate relative from one basis to another. And here is what we have here is vector b, which is the standard ordered basis. In other words, it means that E1 here is 1 0 dimension 2. This one must be 0 and 1. So that is the standard basis. And B prime is given by this one here. Okay. Well, find the transition matrix from B to B prime. So the old one is this, and this is the new one. Okay. Now, before we start with the first step, let me just write down clearly what is b. So b here is just 1 0 0 1, okay, and b prime is negative 1 1 1 and 1. So that is b prime. And I'm going to follow the notation given in the procedure, and therefore I'm going to call this the first vector, vector 1 from the old basis. This is vector 2. So I'm going to call that. And since I know that this is old, this is new, therefore my first step is to try and come up with the linear combination of these two vectors. Must be equal to the first vector here, vector 1, okay, the old vector. So the first step is a1 negative 1 1 from here plus a2 1 and 1 must be equal to the first vector, the old vector, 1 0. So I'm going to call this is the old vector. Remember, this is just a little note for you. Now the next step is, well, b1 for this vector, negative 1 1 plus b2 1 1 from this must equal to the second vector from the old basis, so 0 1. Okay, so this is again a little note. This is the vector 2 from the old basis. Now once we have got that, well, I'm just going to call this equation 1 and equation 2. I'm just going to label that as such. Well, the next our job is to try and get the values of a1 and a2. And how can we do that? Well, based on equation 1, I can consider the augmented matrix. So we have negative 1 1 1 and 1. So here is 1 and 0. And then I can see that this can be turned into 1 by multiplying negative 1 with the first row. So 1, negative 1, negative 1. Okay. Next is I can turn this, sorry, let me just write down 1 1 0. The next part is to turn this into 0. So therefore r2 plus negative 1 r1. So 1 negative 1 negative 1 1 minus 1 0 1 plus 1 2 0 plus 1. Okay, and of course, well, if you want to make it look nicer, you can turn this value into 1. So 1 over 2 with the second row, multiply with the second row. So you have 1 negative 1 negative 1 0 1 1 over 2. Now based on that, well, you can see that here is the value of a2. So a2 is 1 over 2. And then this one here is a1 minus a2, negative 1. a1, negative 1 plus a2, negative 1 plus 1 over 2 is just negative 1 over 2. So this is the value of a1. Right, next is based on equation 2, I can then find the values of b1 and b2 by considering the augmented matrix. And here is 0 and 1. Right, this can be turned into 1 by multiplying negative 1 with the first row. So 1, negative 1, 0. And then 1, 1, 1. And then of course we follow with this one, becomes 0 by considering this process. 1, negative 1, 0. So 1 minus 1, 0. 1 plus 1, 2. 1 plus 0 is 1. And of course, let's just make it look nicer by turning this value into 1. So 1 over 2 R2, 1, negative 1, 0, 0, 1, 1 over 2. Now based on that, I can see that here is the value of B2. B2 must be equal to half. Here is B1 minus B2 is 0. B1 is just B2. And so is equal to half as well. Now from here, we can obtain the transition matrix. Maybe I can use this space or not. Okay, never mind, I just erase this part. Well, erase this. Okay, so I'm just going to erase this. So therefore, the transition matrix is, well, so transition matrix. Okay, so just now we've got the values of A1, A2 that will be filled up on the first column. The value of A1 and A2 is negative 1 over 2 and 1 over 2. So that is for the first column. And for the second column, we're going to consider value of B1 and B2. So B1 is half, so half is here. And B2 is also half, so it will be at the bottom here. So this is the transition matrix, okay? So we are done with the first question. Now next is, here is the given vector, and you are asked to find the coordinate of vector v with respect to the new basis. Again, let us recall what is, or how can we find this coordinate with respect to this new basis. The formula is very simple. You need to find the transition matrix from B to B prime. Yeah, and we have already got the answer here. And you will multiply that with coordinate vector of v with respect to the old basis. Now, the old basis here is the standard ordered basis, is the standard basis. So when you are talking about the coordinate vector relative to the standard basis, the answer is going to be itself. The answer is going to be the vector here itself. We don't need to do anything much, okay? So I'm just going to plug in this value here to the transition matrix, negative half, 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 and half. And here we don't need to do anything much because the basis here is standard. And if it is standard, you can get the coordinate vector relative to that is that vector itself, which is 3 and 4. And if you simplify that process, negative 3 over 2 plus 4 over 2, that will be negative 3 plus 4, this is 1 over 2. And then 3 over 2 plus 4 over 2, 7 over 2. So this is the answer for question B. Okay, that's it for this example here. And before we end this video, this is just a simple theorem. You know, for example, just now what we did is we look at how you can find the transition matrix from B to B prime. And like I said, the notation is sometimes given as this one, from B to B prime. Now, let's say you already got this answer. And the next question is, people say, hey, how do I find the transition matrix from B prime to B? Well, so since you have got this answer, in order to find this value, which is this one here, the transition matrix from B prime to B, what you can do is you can take what you have known here and you find the inverse of this matrix. So that is what this theorem is all about. It is as simple as that, okay? So in order to find the transition matrix of this one, you don't need to do the whole process that we have discussed. Well, since you already know what is this value, you can just use this value. You can just use the transition matrix from B to B prime, and then you find the inverse of it. That will give you the transition matrix from B prime to B. Alright, thank you very much for watching, and see you in the next video.